All right. Hello, everyone. Welcome back. Like I said a while ago, today or this session is going to be shorter as we're just going to go through activities. Then after we go through the activities, I'll go ahead and show you how to install the prerequisites for next week's session where we're building neural networks. So let's get started. Let me just go ahead and share the web browser window. And we're going to go back to the Python introduction file first before jumping into the, this is the way, before jumping into the exercises IPy notebook. So where we left off was me telling you about the statistics from SciPy and being able to do statistics on the data from pandas, red CSVs. Now let's take a look at a real-world example, which is morel hunting. This mushroom, I'm not a mycologist, but Caleb is particularly interested in mycology, and he included this example where morels are pretty ephemeral, so they only grow in certain times of the year, and they're hard to find. Therefore, you need to be there at a specific time of the year in order to collect these morels, and I don't know if I said it already, but they're popularly used for gourmet, popularly used as a gourmet ingredient. So let's go ahead and collect some data of these morels. We're going to be using IDIC-Bio. And so if I go ahead and run this, as you can see, we're importing IDIC-Bio from this data. Now, what IDIC-Bio is essentially, it's a citizen science / database platform that allows you to take just any type of like occurrence record. So if we go ahead and search the portal, we can take occurrence records of particular plants or animals. And so, for example, I'll search for some random plant like Polystichum crossicioides. Polystichum crossicioides. Hopefully I spelled that correctly. And as you can see, it just gives us a bunch of data of all of these like records of Polystichum crossicioides as a type of fern, and when this fern was collected and where it's hosted right now. So as you can see, some were collected as early as 1800s or 1822 or 1855, and some of them are being hosted by the Yale Peabody Museum, so on and so forth. So we're going to be using this data in order to find when to properly, or when the average day of the collection of morels occurs. This would be helpful because, well, if morels only exist in certain times of the year, taking the average day of when they're collected may be a good indication of when you should be collecting this mushroom. So this is a lot of jargon in terms of, how to access the API. This is not something that we're going to be worrying about necessarily. Although if this is applicable to you, you can search up usage through their GitHub and how to query the IDIC-Bio API. But essentially, what you'd expect is a pandas output, which is the return of this API in pandas format. And as you can see, because it's in pandas format, we can actually call it or call pandas functions to this pandas output from IDIC-Bio. So as you can see, pandas generated table, and we have a bunch of information here, including the start day of year, continent, the collection code, et cetera, et cetera. So now, because we wanted to take the average collection date, we can go ahead and clean the data first by saying, okay, make the pandas output delete everything that has a null value or a not applicable value in event date, because that's not going to be helpful for us. If event date is empty, then we're not going to be able to average that. So as you can see, when we do this and run it, we can sample the pandas output at event date. As you can see, we have examples that do have dates on them. Now, what's particularly important is that somewhere along the lines, we're going to have to get the average day, which may not be very useful in this scenario because they're all dates. And when you add dates together, it doesn't really make sense in terms of like adding them together and then dividing the number of samples. So instead, what we use is a column within the pandas data frame called start day of year. If you go ahead and display start day of year, let me go ahead and duplicate this. We can see that these dates are now being translated into the day of the year they correspond to. So 119 actually corresponds to the 119th day of that year. And we can actually go ahead and validate this by just doing some simple arithmetic. If we print out 119 minus the days in the year for January, which is 31, for February, which is 28, and then for March, which is 31, we can see that it corresponds to 29, so April 29. If we do it for 103, we can see that it corresponds to 13, or April 13th. So we know that makes sense. Now, we can go ahead and take the average day of the year, which essentially takes the mean of the start day of year. So it takes the mean of these values. And then we call the mean function. And then there is a parameter within mean, which is skip empty variables. And then we can print that the average day of the year is, well, this is the genus of interest, which is Marcella, and then the dates that we queried from, and then the average collection date, or average collection day. So the average collection day is 100.87875, which doesn't, this decimal obviously not something that's going to be particularly useful. And then you can import another library called datetime. And you essentially take the current date, you take the current year. So from current date, we're taking the day today. Then we're taking the year from the current date. And now what we can do from this current year, which the current year is 2020, we can go ahead and say that the best date is the start of the year plus the time delta between the start of the year and the average day of the year. So when we print that, as you can see now, it took the current year, which is 2020, added this day value to the start of the year day, and then calculated that, okay, the best day for collecting morels is, well, the quote-unquote best day for collecting morels is on April the 10th of this year. So that's a real-world example of how to go ahead and use some kind of data that you have from a particular problem and going from start to collecting your data, cleaning it a little bit, and then doing some very simple statistics. Down here, we have an activity which is essentially to do the same thing, except instead of only collecting from Tennessee, Georgia, North Carolina, and Alabama to the Southeast, we would like you to do it for the Midwest. We're not going to do that right now, but it's actually pretty simple. Instead of setting nearby states to Tennessee, Georgia, North Carolina, and Alabama, that is essentially the state province query that we're giving to IDIC Bio. You would essentially put here things like North Dakota, South Dakota, etc. So you would just replace these nearby states so that when it's given to the API, it will take those states and then do or return you back samples from those states that are collected from those states. All right, so there are additional resources in terms of like the documentation for these libraries, as I know I've just glossed through them. It was particularly a focus of mine to just show you the practical benefits of doing these functions to solve problems. The last thing I'd like to do before going into the actual exercises that I'll be walking through is just the basic arithmetic and logic operators. So in Python, arithmetic is as follows. As you can see, we have the normal addition, subtraction, multiplication, division. We also have floor division, rather, the squared operator, which is double asterisks, as well as the modulo, which is the same for every other programming language. These are the logic operators within Python. The important thing to note is that unlike other programming languages, AND logic, for example, is not double ampersand. It's the actual word AND, or it's not double horizontal line or double vertical lines. It's an actual word OR. Not is both not and also the exclamation sign for people who are aware of programming. And then others such as more than, less than, and equal to are pretty the same as other programming languages. Note that what confuses most beginners is the equals to sign, where often you would like to say that, for example, x equals 5. In math, it would mean that x is equivalent to 5, but x is being assigned 5 in Python and in most programming languages. To do an equality, you would do x equals 5. And then, as I've said before, assignment is equals. We can add, subtract, multiply, and divide, floor divide to, and modulo to a specific variable without having to separate the operators. Lastly, there's an example here of how to load actual Python scripts into Jupyter. This is not particularly important just because most of the time you'd be working in Jupyter if you're running a Jupyter notebook. But if you have a Python file that you'd like to load into Jupyter, you can go ahead and type load, and then the file name of your Python file. When you click enter in here, when you click enter in here, it will load the Python file. As you can see, it says value error, file name.py was not found, and that's because I don't have a file name.py in my directory. But essentially what will happen is that this code cell would become file name.py and all of its content. So that's an easy way to load Python scripts into a Jupyter notebook. Now, let's get into the exercises. So the exercises may be found in the exercises.ipy notebook file if you're following along with the Python bootcamp files. There are some activities here that I'm going to go over. They are simple programming problems or tasks. What I will try to do, in addition to explaining it the long, easy to understand way, is to explain it the short Pythonic way, such as making list comprehensions. You can already see a list comprehension inside here, where I essentially generate a random integer inside of a list with a for loop inside the list, make a generator, and then the list takes the value of this generator. So I'll be going through an easy to understand method, but also be going through a Pythonic methods such as this one, which are shorter and more indicative of programming language. So let's get started. Activity number 1, concatenate the generated lists, list 1 and list 2, together and sort them. So this is pretty easy. If I wanted to sort these, if I wanted to concatenate these lists together, list C equals list 1 plus list 2. Remember that when you do the addition operator on two lists, it concatenates them together. So if I go ahead and print list 1, list 2, and list C, we can see that list 1 is this, list 2 is this, and the concatenated list is, well, this third list. In order to sort this, it's also pretty simple. Lists have a sort function, so you can go ahead and call list c.sort. Now, when I print list C, and it's going to auto-generate a new two new lists, as you can see, list C is now sorted from in ascending order. So 24 to 897. Now, particularly interesting to note is that you shouldn't assign list C to this function. And the reason why is because sort is actually a void function. It doesn't have a return statement. So if you assign list C to whatever this evaluates to, it'll evaluate to none because it's returning nothing. And that's why list C is now none. So you want to call it by itself. That's a particularly bad gotcha of Python, is that there are multiple ways to do, or there are seemingly different routes to do the same thing. It's, for example, if you have list c.sort, but then if you want to take the max of the list, you don't do list c.max. You actually do list max of list C, which is particularly confusing because when do you use this notation versus this notation? But that's essentially how to sort, concatenate and sort the list. This is the fastest way of doing this. You could potentially try and make this into a one-liner or shorter, but the problem is that because it returns a nothing value, it's hard to do it with list comprehension. Activity 2, make a list with even numbers from 0 to 100 using a for loop. So as you can see here, we have an expected output, and it's basically a list from 0 to 100 and only the even numbers. There are multiple ways to do this. The easiest way, or the easiest to understand way, is to make an empty list. So my list equals the empty list. Then for number in range, and for other programmers, you can say for I in range, I'll just use number in range of, now remember, as I've said, range takes a similar notation to standard for loops in other programming languages. If you're not familiar with other programming languages, it's essentially the first value is the start. The second value is the end, not inclusive. So we do want to do 101. If we do 100, it would stop before it appended 100. And we want the step value. Since we're starting at 0, if we add 2, it will never hit an odd number. It's because we're adding 2 to 0 to get 2, 2 to 2 to get 4, so on and so forth. So we know that we'd always hit even numbers. Easy enough to do this with odd numbers. We just change this to 1, and it'll go 1, 3, 5, 7, so on and so forth. Then we essentially just append number to my list. So my list dot append number. When we go ahead and do that and print my list, as you can see, we get a list from 0 to 100 and only the even numbers. If we change the stop value to 100 instead of 101, you can see that because 100 was not included, it stopped, and therefore 100 is now missing from this list. A simpler or a shorter way of doing this is actually to do list comprehension, which is more Pythonic. You can essentially scrap all of this and say, my list is equals to a list, and then you would create a generator. So value, or let's just use the old variable name, number for number in range of 0, 101, and 2. When we print that, we get the exact same thing. We can even make sure that it's printing a new list, just to make sure that it's actually printing what we made here. And then an even shorter way of doing this is actually to look at how this range function works. This is a peculiarity of Python and how to use a for loop with indices, sorry. If we look at range, so let's go ahead and print range. It generates a range object. However, if we actually go ahead and cast this, so transform it into a list, you can see that it's what range is actually generating is a list from 0 to 100, given the same parameters that we gave it. So why the for loop? For example, if we had a list, my other list, and we said we populate this, let's say DAX and hello and 0. If we did for I in range of, let's just use the other programming notation, the start is 0, the end is length of the other list, and the step is 1. Oops, print my other list at the index I. As you can see, we get DAX hello and 0. However, if we print this out, or we change it into a list and print it out, we can see that it's actually just generating a list of indices. It's generating 0, 1, and 2 as a list, which is a lot like just doing my other list for value in my other list, print my other, or print value. And it functionally does the same thing. It prints the value for every value within my other list. So when it generates this range, it's essentially iterating over another list that contains 0, 1, and 2, and that's what it takes as indices, which is one of the reasons, it's not the sole reason, but it's one of the reasons why people say that Python can do things very slowly. Why are you essentially making another list just to store indices instead of just iterating a singular variable that's not an array or a list, right? That would be a lot faster and more efficient. But given that weirdness aside, if we wanted to do this very simply, the easiest way is to go ahead and just say to print a list of range of even numbers. And that's all you need for that. Activity number 3 is to create a function that takes a list and returns a list with all of the values squared. So here we have a generated list, list 1, and now we're tasked to create a function. So that's pretty simple to do. We essentially can define a function squared list, and then parentheses for the parameters we want to add. And we'll just say user list. And then we essentially just square all the values and then return those values. So we can go ahead and say, for example, a temporary list equals an empty list. And then for each value in user list, so this becomes this, we can say to append to the temporary list the value squared. After that, we can just return the temporary list. Now, when we called squared list, we can go ahead and call the squared list function and then pass in list one. Print this out. And as you can see, it squared everything within our original list. So for people who have trouble trying to follow, in squared list, list one, the thing we pass into the function, becomes user list in the function, becomes an implicit parameter. Taking user list, which is list one, we create an empty list, append to the empty list values within the user list, but squared. So we're squaring the values and then appending them to this temporary list. Then lastly, we return the temporary list. There is a shorter way to do this, which is to essentially return a list comprehension. So we can do user list again. And then we can return a list. So you can return just raw arrays like this if you wanted to. There's nothing limiting you from doing that. So we can return value for value, or value squared, sorry, for value in the user list. When we print squared list one of list one, as you can see, that also worked. 5 became 25, 10 became 100, 2 became 4, etc. But that's still not the fastest way of doing that. If people are familiar with programming an anonymous function, you can go ahead and create the lambda function to do the exact same thing. So you could say something like x equals lambda, or let's say squared list 2. Lambda user list, and then return the variable or return the list that we wanted, squared list 2. So now we just created a lambda function wherein lambda of, this is the parameter we're passing in, this is the expression we want out of it. When we print squared list 2 of list 1, it does functionally the same thing. So there is an easy to understand way, there's a list comprehension way, and there's a way to do it with anonymous functions. Activity 4, read the Aristotose dataset and display the petal length column. So in order to do this, it's important to be aware of your working directory and just knowing what file name it is. So you want to load from the Aristotose dataset, which I hopefully you guys can see this. There's an aristotose.csv file within the Python bootcamp folder. So in order to read that file, you just set data frame equals pandas.readcsv because it's a CSV file. And then the CSV is aristotose.csv. So now you load this CSV file into a data frame. Then you can select columns by just reassigning the data frame. So data frame equals the data frame and only the petal length column. So you give it a key. If you wanted to put multiple columns, you give it a list as a key, and then you can put things like petal length, sepal length, etc. And then lastly, you just display the data frame's head. So you can go ahead and run that. And as you can see, we get the exact same output as what's expected here, where we took the petal length and only displayed the head. Activity number 5, round a float with decimals to an integer without using round. So here I generate a random float number every time the code is run. I can go ahead and print the float number. And if we keep running this, we see that it takes on different values. As you know, there is a round function. So if I go ahead and actually, let's just do this. We can round numbers using the round function, but it told us not to use the round function. So what do we do? Well, there are several ways in order to solve this. The first is through floor division, and the second is through casting. So floor division is essentially, say for example, float num equals float num divided by 1. Or let's say int num instead. If we print this, floor division is essentially just dividing the float number or the decimal number and just taking away all of the decimal. So it essentially removes all of the decimal within this float. So 1.2 becomes 1, 7.8 becomes 7 because it's floor dividing, taking the floor value. Now this is pretty helpful because then we can subtract, right, the float num to the int num. So let's say if the float number minus the int number is more than or equals to 0.5, then we can round it up. We can say int number plus equals or equals int number plus 1. And so now what we're doing is that if, for example, the difference between 7.8 and 7 is more than 0.5, then we can just add to the integer number 1 because it will be rounding up. If not, then this code never runs. So if we run this, as you can see, 8.97 becomes 9. 9.2 becomes 9. 2.2 becomes 2, so on and so forth. You can also just cast it. So instead of doing floor division, where we're taking the original number and then floor dividing it by 1 to give the original number without the decimal places, you can also just do integer and then float number. It essentially turns this float with decimals into an integer, which, as you may know, removes or doesn't have any decimal places. As you can see now, there's no decimal place within this number anymore. Before, this would resolve to 8.0 or 8.0. Now it's just 8. So it took away all of the decimal places within this original int number. There is a faster way to do something like this, which is essentially to just make this into a one-line if statement. So you can say something like int num plus 1 if float num minus int num is more than or equal to 0.5, else int num. Oh, and we should print the float num as well. So now we just created a one-line if statement. You can simplify this even further by just removing this entirely, right? So you can go ahead and say int float num plus 1 if float num minus int float num is more than or equals to 2.5, else just return the original. And as you can see, that also works. Now you saved a line. Not the most efficient, obviously, because you're calling this casting multiple times. And so really it's better to just do it once. But you can simplify code or like shorten code in this manner. Activity 6, create code that converts the provided messy mixed list into a dictionary. So as you can see, we have a mixed list of multiple data types. We have a string, an integer, a birthday. That's not a birthday, but whatever. And then a name and an answer, and we have a complex variable here. What it would like us to do is give us an expected output like this. Now, the easiest way to do this is actually through just assigning variables to a dictionary. So let's say my dictionary equals an empty dictionary. We can go ahead and just say the mixed list at this variable, right? So let's try to capture this variable by popping it. So, or sorry, we should do my dictionary. Mixed list dot pop at the index 0 equals mixed list dot pop at the index 0. So what this does is essentially, okay, my dictionary, take this variable out and put it into the key, and then set it as whatever this new list resolves to, take that index at 0 and put it into the assignment. It actually doesn't work this way. And the reason why is because this on value actually resolves first. So this wouldn't work because this would then become, this value would then become lucky number, and this value, this key would now become 7. So everything is switched. So we'd actually like to do something like this, where at mixed list pop the variable at index 1, set it as my assignment, so this becomes 7. And then, because it's a pop, it also deletes the element at the list, so now that goes away. And then mixed list dot pop 0, that resolves into lucky number. Go ahead and do that, and it becomes this instead. So this list, after the first try, becomes my dictionary lucky number equals 7, which is like what we saw before, assigning a value to a key. Now we have to do this for all of the other ones using a for loop, but also removing these non-variable. So that's easy enough to do. We can make a for loop, or not a for loop, but a while loop to make sure, since we're going with the popping method, let's go ahead and do that. Since we're going into the popping method, we know that this list is going to continue to shrink. So it's going to continue to lose values, right? And so what we want to do with the while loop is make sure that the mixed list is not empty at the end of it all. It doesn't continue running while it's empty. So while the length of the mixed list is not equals to 0, so there's things within the list, let's go ahead and do something like this, where we pop the first value and then the second value. However, we're not really checking this none type. So what we need to do is essentially put an if statement. So we need to check if the if statement, or at the if statement, if this is not none. So we can do that by saying if mixed list at the index of 0, since we're going to be continuously deleting the first and second variable in this, if the index at 0, let's say it ran through the first time, is not equals to none, and there's another way to say this, which is more Pythonic and is preferred, which is not none, go ahead and pop these variables. So let's say the first index in this list is not none. Now you can go ahead and mixed list pop 1, so this becomes 224, and then mixed list, and this goes away because it's a pop, so delete. Mixed list dot pop 0, this resolves to birthday, and so you end up with a dictionary assignment. If it's not none, do that, but we have none. So if mixed list at 0 is none, we can go ahead and just delete the mixed list at 0. So we just go ahead, if it is none, then we're just going to delete. Then the next time it runs, it will say that, oh, this is not none, so I'm going to pop 224 and put it here. I'm going to pop birthday and put it in here, and then this goes away. And then the next time it says it's none, so it deletes it. Next time it says it's none, so it deletes it, so on and so forth. So let's go ahead and just put it back to where it was, lucky number and 7. And print my dictionary. As you can see, it failed, saying that the list index is out of range, which would mean that the actual list, when it gets to here, is empty. Else if this. Oops. Okay. Let's go ahead and debug this really quickly. If the element at 0 is none, go ahead and run that. And then print my dictionary. Interesting. I'm going to go ahead and rerun my Jupyter notebook just because it seems like it is not updating, or it's not printing
I have a suggestion.
Mhm.
I think you want your while statement to just be, oh, no, I'm sorry. I misspoke. Never mind. Sorry.
Didn't delete in the if statement. What's interesting is that it's actually not printing anything, including hello, which, oh, it's because this while statement never ends. That makes sense. So let's go ahead and debug this. If it's not none, then we pop the first two indices. If it is none, then we delete the mixed list at 0.
Zero is the first index, right? So it just
Yes.
highlighted the first index.
So the solution would be, so these two would pop these two indices.
Okay.
Then it reruns again. And now the first index is none, and it deletes this. Then the next time it runs this, deletes the next two. Next time it runs, it deletes none, then it deletes none, and then it takes these two and deletes these two as a pair, and then deletes these two, and then it's empty. Let's go ahead and reload.
So why are you using delete? You are not using pop.
I'm sorry?
Why you are using else if delete? Why you don't use pop?
I'm sorry, it's like very hard to hear you.
Change your delete mixed list to pop, or mixed list 0.pop.
Pop 0. Yes. Okay. And take delete out.
Text.
Yep.
So what's the why the after else you need a mixed list 0? Else should be closer, right?
Oh, yeah. Why is this here? That's true. What's interesting is now my Python interpreter is just not working. Restart this. Go ahead and run that. That is very interesting.
Something's wrong with Jupyter, right? Are you Jupyter?
Yeah, something seems to be wrong with Jupyter rather than anything else now.
How about other people? Anybody pass this code?
Oops, it's connecting to kernel. Hold on. Restart. Here we go. Yeah, interestingly, now it just doesn't want to do my Jupyter. Hopefully you guys can see my PowerShell prompt, but this is really concerning because I never had this happen before.
Are you hitting run or are you hitting something else on in Jupyter? Because I keep seeing
So I'm hitting the shortcut, which is Shift Enter, and that's the run command.
Okay, thank you.
So I believe, yeah, you can run salts using Control Enter, run salt and select the lowest Shift Enter, and that's essentially what I'm doing. Shift Enter, it runs this and then selects the next salt. Interestingly enough, no, now my thing doesn't work. So there's that. We can go ahead and just kill all of these, I guess. And go back here. Go into here, run this. Okay, now it's working. I really had to hard reset the entire thing. All right. Print type is dictionary, print my dict. There we go, that works. Now, at this point, I'm not even sure if like the old code worked and it just didn't want to print out anything, or what. I believe the old code was elif mixed list at 0 is none. And I had delete mixed list at 0. Yeah, that worked. Okay, I don't know what happened to Python. I deeply apologize for that, but it seems like this now works. Let's just change the variables really quick to make sure that it actually is working. Mixed list at 1, and then mixed at 1, print. Yeah, it does. Well, or maybe it doesn't. Mixed linked. There we go. Yeah, it does work. So if we print my dict of 1 and just use this code, it does work. I don't know what happened a while ago. I guess Jupyter just wanted to troll me. Sorry about that, guys. But yeah, so running over the thing again, take the first variable or the second variable and put it as assignment because that runs first. Take the first element and pop that, and that gets put into a key. These both get deleted. And then the next time it runs, it will essentially hit this none, and it will delete the first index. So boom, and then continue this cycle over and over. It is true, however, that you don't need to do this. You can just put else. You can do elif, but elif is just better because it doesn't need to check a conditional. It just breaks into this whole block. So that's essentially how to solve activity number 6. There is a shorter way of doing this, funnily enough, and it is through dictionary or just through list comprehension again. So you can go ahead and redefine mixed list equals mixed, or well, value for value in mixed list if value is not none. When we print out mixed list, we get the entire list just without the none variables. And then in order to create a dictionary, you can just do comprehension in this manner, where you can essentially put a key, colon, a value, and then you continue your normal list comprehension. So for us, we want our key to be mixed list dot top 0 mixed list dot top 0. So this will, I believe this evaluates first and then the value evaluates, so you don't need to put 1 here. For whatever in range of the half of this list, because we're going to be iterating through half of this, and because we have a length of 8 at the end of it all, so 0, 1, 2, 3, 4, 5, 6, 7, 8, we'd want to have a range that is half of this. So the length of the mixed list divided by 2. And then we print my dictionary. Oh, we do have to do 1 here. Okay. So this still evaluates, like the assignment still evaluates first and then this evaluate. So we pop the first index, this goes to 7 here, then the value at index 0, and that goes to lucky number here. Important to note is underscore. Underscore means like a throwaway value or the last value within the Python interpreter. And then also important to note is how I casted this to an int. And that's because if I don't cast it to an int, I believe it will throw an error. Yeah, it will throw this error in which you can't use a float object as a range parameter. It has to be an int. And that's because when you print this, it resolves. Let me put this above. It resolves to 4.0, not 4. And it is expecting 4, which is an integer value. So that's why an integer has to be there. So this is the shorter way of doing the exact same thing I did a while ago.
So Dex, I have a question. So
Yes.
right now you have the even number of the element in the list, but if there's odd number, there might be some problems.
Yes, there will be problems. What's important to note is that you're given this type of list where this is an assumption that students will have to make, that keys are always followed by their value. So this key is always followed by this value, this key is always followed by this value, so on and so forth. If certain keys, quote unquote keys, are losing values such as this, then yes, this code will break. But then that becomes a very difficult problem because you don't necessarily know which is a key and which is a value. You could do something like checking for types, right? So if you know all of your values are integers, you can just check the types of whatever this is and whatever this is. And if it's a string, it's a key. If it's a integer or float, it's a value. But as you can see here, we have several different types, and we also have some values that are strings, which makes it kind of impossible to check which is a string or which is a key and which is a value. So this is an assumption that people are going to have to make. Anyway, so yeah, this solution is only for this example. Or examples like this where there's none sprinkled everywhere, so on and so forth. But the keys is always followed by a value. It's not followed by a non-variable, etc., etc. Activity 7. Yes?
So if your lucky number was actually none and not the number 7, would that fail?
Yes, this would fail.
I mean,
Oh,
what
well,
if you
this
put it
won't
in,
fail.
if you put it
This
in,
won't. Oh, sorry.
if you put it in quotes, I mean, what if the value was actually none?
Oh, if you wanted a value of none, you can put it in quote and it becomes a string. This actually doesn't fail. And it's because it'll put this into this value and then this lucky number into this value. It will never actually see that this value is none because it only checks none for the first item or the 0th index. So I'm pretty sure if I print my deck here, yeah, it prints lucky number and an empty value. If you want it to actually be none, you can just put it as a string. And now you can see that lucky number has a string value of none.
Thank you.
No problem. Okay. Any other questions in terms of that? I know I had like some technical difficulties, so I apologize. If you guys have any questions, just feel free to interrupt me.
One just quick question. That mixed list second line, actually you are filtering the list item which not equal to none. Then how it carries again to the third line, because both the variable name is same, mixed underscore list.
Oh, that is because, so for example, if I print this out, this is popped, so let's not do that. If I print the actual list that was generated, or a list with a list generator, it resolves to this. Now, what I'm doing is I'm assigning mixed list, this variable, to this value. So I'm assigning this as the value to mixed list. So essentially, it carries over to my dictionary because I have redefined mixed list. It's kind of similar to if you said something like x equals 5, and then x equals 4, and then print like something like x plus 5, and this will become 9 because you reassigned it. And then if you're wondering, okay, mixed list, and then I have mixed list in the actual assignment, how does it resolve that? Well, what always happens is that this always resolves first, which means that mixed list didn't take the value, the mixed list is not being taken a value yet. It will resolve this first, which is the same as essentially just doing this, right? So you're essentially just resolving this syntax first. So it will return the old, this is the old mixed list. And then inside of this list, you're just putting every value that's not none within the old mixed list. After it's done with the old mixed list, it then assigns this entire new generated list into mixed list again. So now this becomes the new mixed list. So in summary, there's a reassignment of mixed list, and the old mixed list that's found in here will never be thrown away until this actually resolves first, and then it's reassigned to mixed list. I don't know if that answered your question. Feel free to let me know.
Yeah, that's what I was initially having the understanding. Then when you put none for the lucky number, like with not a string, direct none, then how it identifies as a blank, because next to lucky number will be birthday that time.
Right. So this time, so I believe your question is this.
Yeah, correct.
The actual non-data type.
Yeah.
So the reason why it actually takes none as a blank, I need to go ahead and mix value for value, and then I need to go ahead and print mixed list. Oops. Or the dictionary itself. If lucky number is, yeah, you're right. It actually didn't resolve. As you can see, well, if the lucky number is blank, so this is blank, but then it didn't resolve properly because now Bob became answer.
Correct.
Because we're only iterating over a range divided by 2.
Yeah.
So this actually, yeah, you're right. This actually went away because this popped and then it took this away. Or this got deleted, so these are gone.
Yeah. Yeah.
So lucky number is now birthday. Yes, you're correct.
Thank you.
No problem. Sorry about that. Yeah, this would all get deleted. Go ahead and change that back. So in summary, the question was why none here would not be resolved. Well, it actually wouldn't be resolved because it would be deleted by this next line. And that's why lucky number is equal to birthday. Ooh, any other questions? That time I actually did mess up, so if you guys have any other questions, feel free to let me know. All right. Activity number 7. Create a function that returns the highest number value with the list generated through the provided code. So this is actually pretty simple. So you just want a function that returns the highest number value. So we'll go ahead and define my max and then user list. So we'll go through the motions of creating a function again. And then we will go ahead and just return the maximum of this list. Now, some amongst you might just want to do max of list 1, and that's fine. That's no fun because you're actually just using another function to define your own max function. The fastest way to get a max is just the linear, like scanning through an array. So we'll say that highest number. Now you can say negative infinity, but as you can see here, I'm generating a random int from 0 to 1000. You can just say that the highest number is 0. And then for number in user list, if number is more than 4 equals or just more than the highest number, then the highest number is equals to the number. Then you just return the highest number. Then when we call my max of list 1, we can see that the generated list is this list and the highest number is 972, and we printed out 972. There are shorter ways of doing this. I mean, this is the fastest way of doing it because this, as if you've taken algorithms, this is big O of n. And therefore, when you take the maximum of any list and you sort it, it's always going to be slower. Any sorting algorithm is slower than linear time, unless the list is already sorted, in which it's constant time. If you want the highest number, you either take the start or the end, depending on how it's sorted. There is a shorter way of, like I said, there is a shorter way of doing this where you just do my max of 1 user list, and you essentially just return, well, you would do temp equals user list, and then temp dot sort, and then you would essentially just return temp at -1. So -1 is the last item in the list, and you're just returning it after sorted, but this would be slower. And then you can also do something like composing functions where you essentially just return max, if you would like to compose functions that way. Last activity. Okay, so here we create a function that takes the frequency of each letter with the provided string and outputs the values to a dictionary. So I essentially just take this string and I add it into a dictionary. So we can see here that E appears 3 times in this string. Seems, so that's 2E, like, that's 1E, and then there's no more E's in the rest of the strings, so E had a value of 3. The easiest way to do this is to do the same thing that we did a while ago, which is essentially to just say string 1 at the dictionary of some key, let's start with S. Now I did say it should not be case sensitive, so let's just say lowercase s. And then we just add 1 to it, right? So we add 1 to a key at F. Obviously, the problem to this is that there's going to be a key error in which it will say, hey, there's no key within this dictionary that corresponds to F. If we add that in, then yes, it will work. If we print this out, we can see that it works. But we want to do this programmatically, obviously. And so here, I'd like to talk about try-catch statements, or in Python, try-except statements. So try-except statements are essentially statements that handles exceptions. So when we run this, we can see that, oops, let's go ahead and delete that. We can see that we get a key error. If we wanted to handle this key error, we can essentially wrap our code within a try-except statement. And that's how you do that. Try to do this statement, right? Except if it finds an exception, and for us, this exception is key error. So exception key error. Now we can define it to do some other thing if this fails. So for us, we'd like to assign it a variable because we can't do arithmetic on it. We just want to assign a variable to this key so that it creates the key in the dictionary. So for here, we'll just set it to 1. Because every time it sees this character, it will just add, or it will just set it to 1 if it doesn't already exist within the dictionary. So now we can go about, if we run this, it doesn't error out. And that's because if we print string 1 at string 1 dictionary, we can see that it actually assigned to key S the value of 1. Now we can actually go about just solving the rest of this. So first, we didn't want it to be case sensitive. And in my example, all of these were lowercase. So you can just say string 1 dot lower. You can call functions on arbitrary strings. So here we're setting string 1 to be the lowercase version of this. And then we can go ahead and just iterate through the string. So for value, or let's just say character, in string 1, colon, and then we run the try-except statement. Now, we don't want to be adding S to the string 1 dictionary. We wanting to add the character as the key to the dictionary, or as the key to these values. And so it will hit S. It will say, OK, there's no key S, so I'm going to set S to 1. It will hit E. It will say, OK, there's no character that's E, so I'll assign E to 1. It hits the second E, and then now it will try to run this statement, and it will pass because character E exists. So it will add 1 to the key E, and it will become 2. Go ahead and run this. As you can see, it has successfully went through the entire string with the frequencies for each and every letter that it encountered. There isn't really quite a way to shorten this due to the reliance of try-except statements. So there's no easier way to do this, at least as far as I know, or at least as far as my Python capabilities are concerned. But yeah, any questions?
It's only 2 E's, right? Sorry, I may be looking wrong.
Is there multiple A's? So 2 A's.
3, 4.
So it seems like it's going to rain 1 A. Thursday is the second A.
E is 2 E's. S is 3.
Oh, E's. E's, so here's the first two E's. Let me just zoom in. Here's the first two E's, which is seems. And then the third E is in like. And
That's
then
I'm sorry.
going to rain this Thursday. Yeah, so there are three E's.
Can you sort the dictionaries by the key or something like that?
I'm sorry?
Can you sort dictionaries by key? Or
Oh, so can you sort by dictionaries? Or can you sort dictionaries? You can sort the arrays of the dictionaries. So let me just zoom in. Oh, this is way too zoomed out. You can sort the arrays of the dictionary or the arrays of the dictionaries, like say, for example, string 1 dict.keys, and you get the keys for this, and then string 1 dict values, and you get the values for this, and then you essentially do a double sort where for every time you sort this, you update the array here. So let me just make sure this resolves, just to make sure that, yeah, so you can do this, and then you can essentially also have this. And so for each of these keys, you would have these values. And then you can essentially create a new dictionary. I'm not too sure of how to do it in the short form, but you'll essentially create a new dictionary, let's say dict1, for every, you sort this, and then you sort this values in the same way as you sorted this first array. And then you just do kv for keys value, or kv and zip keys values. So you do something like that. So if you'd like to sort your dictionary, you'd have to do it in a kind of nuanced way by converting it to a list, doing the sort on these lists, and then redefining your dictionary again. There's no easy way to do it just with a dictionary, just because they're like sets. They don't have like certain indices. They don't have indices.
Thank you.
No problem. In terms of sorting dictionaries, there's a very short way to do it, but I don't quite remember how to do it. So there's that.
Is there a sorted method like that? Take the key items, what you did is right, and then sorted off dictionary items, then print it.
So you would
using
print a
the
dictionary
word sorted, SORTED.
sorted. Is it sorted? Okay, so KV for KV in sorted. And then we have string on dict keys. Dictionary items. I don't think that's not the case. It would actually just be this. Oops. Might be. Oops. That and this. Yeah, no. I definitely don't know. I definitely don't know right now, at least, to do it in a one-liner method. Sorting dictionary through generator. Yeah. I don't know if there is a way. There is a way, I just don't know how to do it in one line. Here's like another way of doing that. Oh, yeah, this seems very nuanced though. You would have to use sorted, then you'd sort the keys, and then it'll give you out a tuple of the indices for this. Seems like, yeah, and then through that you can take the actual indices of where they need to go, and then you replace or you place the keys at this value at this indices in your dictionary, and then you'd have to, yeah, here it is. For key in KV of 1 and KV of 0. This is closer to what I thought, but there was an even easier way of doing something like this. Oh, and there's also ordered dictionary. Well, there we go. Here's your answer. Just import collections or import ordered dictionary from collections, and then you can just have an ordered dict. I didn't know this actually existed, so there's that. Anyway.
Do you want to try getting a count of all the characters that are not in that string? Or not a count so much, but get a list of all the characters that are not in that string? Alphabetical characters?
So all of the characters that are not in the string. Okay, so we can.
Yeah, A to Z.
The easiest way actually to do that, at least, we'll keep this value and this value. We'll keep this as well. So the easiest way is to just define another string of the values that you want. Gosh, there was a way to get just all of the alphabetical strings, but let's see, check string equals, and you would just essentially do A, B, C, D, E, F, G, H, I, J, K.
Does range work on that?
Now, this sucks. I believe Python get alphabet string. And it's string.ASCII lowercase. So we'd import string. There we go. So we can just replace it with this. So here's all the lowercase strings. We can essentially just create our dictionary using this. So K and 0 for K in this. That should work. Okay, cool. Yes, it did work, but it printed it just with everything as well. And then we don't even need this try except statement because we can assure that this exists, but let's just keep that code. Okay, so we instantiate a dictionary with all of the letters that we're expecting. Then we go ahead and run the second code, which just adds everything. And then we essentially just do a check. Actually, if we just wanted to check if the character existed, this actually is a little too much.
Would you look for the value equal to 0 and print that?
Yeah, so yeah, what you would do next is just for every key in this string dict, dot keys, if key is equals to 0, or not that, if string 1 dict at the key is equals to 0, print that value or that key. So these are the letters that don't exist within the string. But this seems a little too much. What may be better is actually just saying you would do everything string 1 dict chars equals this, and then
comparing the list, like first dictionary, if that letter exists or not. Is that
yeah,
so?
if the letter, yeah, I would essentially, where I was going was instead of counting here, this doesn't need to be here anymore, but instead of counting here, you would just like write true. But then you could also just say that for string or for character in this, oh gosh, multi-line editing. Sorry, for character in this, if character is not in string 1, print the character.
Could you use the intersect and compare them as sets instead of as dictionary? If you counted the string 1 as a set instead, and then
Oh, yeah, you could as well, actually.
and then
Yeah,
just
you
do
could.
an intersection or a not intersecting.
Yeah, you would have to do a not intersecting. Is there a find method? Yes, there is a find method. Or is there not? Never mind, I guess I lied. I for sure thought there was a find method, but I guess there's not. Which is weird because there is a remove method, which you put in a value. So not an index, you put in an actual value. The index is delete. So
Yeah,
I don't know why there isn't a find method.
On the string, not the list, not on the list. Find method. String dot find of.
String has a find method, but not a list. That's so interesting. Why? Okay. Yeah, I guess there isn't. I know strings have this, which is replace. You can replace seams with like, let's replace it with zygophilaceae. Okay. And then for, dot lower. Okay, so now Z is not within this. So there's a replace, which would also denote a need for finding something, because I replaced seams with zygophilaceae.
Yeah, it may not be able like directly because we need to compare each character. So in the file, take each character from the alphabet list and check if that character exists in the string 1, like that. String 1 dot find of A, string 1 of dot find of B, like that. I'm not sure if
yeah, so you keep finding. So actually, the thing about, so find would be, I think, most helpful, I guess, if you need the index of where it's at. here, what we're doing is doing the in keyword. So the in keyword actually tries to find a sequence of whatever in the string. So say, for example, this character doesn't need to be character, it doesn't need to be this. It can be seams as well. But so this character can be an entire string. And then you try to find strings within the actual string. So if string is not in this string, but this obviously just doing this, it has no way to know what the indices is. So I guess find would be helpful if you were doing for character in ASCII lowercase and you did some kind of like enumerate and here. This is a bit more, a bit out of scope, but essentially you have an index and then big string 1 at the index. Or, oh, you would have to do this the opposite way, but essentially you would take the index of the string and then keep finding where it may not be found.
Yeah, like just loop that ASCII characters, and if not character is not required. Actually, there is a it will return the position value if it exists. String dot find of character S, for example, it will if returns -1, I think it's not exist.
Cool. Let's see. String 1 dot find, and then we'll try to find the character itself.
Character, yeah, correct. Yeah.
Let's see if I'm not sure if it's a.
Try.
Oh yeah! Whoa! Holy. Let's go ahead and take that away. Yeah, here we go. So this is actually pretty cool. It says that this character A, I'm guessing, is found at 27. I'm not going to count that, but that seems correct. There seems like it's in position 27. And then B is not in the string, so it's -1. Although, I don't know if it can actually do multiple things. If I change this, yeah, it changed to 41. So it's whatever it hits first.
Yeah,
so
it's
it
gonna,
hit A first.
It's going to report what's the first position that it found. You have to go, if you want to find other positions, you'd have to loop through it.
Yeah. Mm-hmm. At least one time, if it exists or not, this will work. Yeah. How many times it exists, then the other way around, what you already read on the program.
This is actually pretty helpful because then you can, if you had the list, if this was a list instead, you can do something like if string 1 was the list dot pop, and then you pop it at the first found index, right? So now you have the index, and then you can pop the first found index only knowing the value, but not where it is, which is actually really cool. You can go ahead and compose that function this way, assuming that this was a list instead of a string. So interesting. Oh, but then to be fair, if that was a string, then find wouldn't even exist. Oh, that's so sad. Never mind. I thought that was cool, but for whatever reason, Python doesn't have a find method for list. I want to double check that. Interesting. Is it index? No. Well, I don't think so, at least. Oh, no, this is, yeah, this is correct. Hold on. Yeah, there we go. It's index. Yeah, that was really concerning that I didn't have a find method for, well, is that true if it was an array?
It's actually
Let's see.
already returns -1 if character does not exist.
Oh, well, see, the problem is that I'm using index. So this actually errors out to a value error because I'm not using find.
Okay.
What I wanted to try was actually making this a list instead. So list string 1 equals, let's see, C4C in string 1. And let's just do that. Yeah, that works. So your find method in arrays or in lists is actually just index. Cool. And as I said before, because this has a value error, this had to be done for index. But if you were doing strength and you were doing find, you don't need this at all. All right, that was a lot of things. Are there any other questions or things you would like to talk about in terms of the activities before I get ahead or go ahead and teach you how to install the prerequisites for next week for the neural network doc? All right, I'm taking that as there are no questions. So in terms of, oh gosh, where did everything go? In terms of installing things, it's actually pretty simple. So, ooh, do I not have a, yeah, I do. So here's Anaconda PowerShell prompt. If you were on macOS and you'd like to do the same things, you would open your terminal instead. For people on Windows, you would want to open, just search Anaconda PowerShell, and it should be under PowerShell prompt. And then instead of Miniconda 3, you'd have Anaconda 3. Do this. When you open your Anaconda prompt, or when you open your terminal in macOS, you'll be greeted into something similar to this. Now, for the things we need next week, all we need is basically sklearn. So for this, I'd recommend that you create an environment, but for the purposes of this tutorial, I won't. So I'm going to create a new environment for myself, but you don't need to follow what I'm doing. Essentially, the reason why I'm doing this is because I don't want to mess up my base environment. And then once this finishes, I'll go ahead and just activate this environment. And so from here, like I said, you didn't need to do anything that I did a while ago. To install the prerequisites we need for next week, just go ahead and type in pip install sklearn. That's all you need. It will essentially download sklearn, and then it will essentially install it, and you should be good. In terms of checking if you do have sklearn, we're going to wait for this to install, I guess. Actually, while we wait, I'd like to explain what sklearn even is. So we'll go here. Scikit-learn. So scikit-learn is a machine learning library in Python. It's incredibly easy to use. In fact, there are many different means for you to actually just use predefined model. So say, for example, if you want to use a predefined random forest or SVM, or you wanted to do clustering or dimensionality reduction, sklearn has a ton of functions to do that automatically. Or well, not automatically, but you don't need to define these models yourself. That being said, it is also pretty limited in what it can do. This will be a great starting point for us, at least, as we delve into a project that really cements all of these concepts, including how to define like multi-layer perceptron model. I'm going to go ahead and check if it's done, and yes, it is. Oops. Stop share and go back here. As you can see, we successfully built sklearn. And if you want to know if it's already installed, you can do pip show sklearn or pip show scikit-learn. If you do scikit-learn, you see that scikit-learn 0.23.2. The reason why, if I do sklearn, it shows 0.0, it essentially, this name just wraps the entire name, which is scikit-learn, which is this. So there we go, deactivate. And that way we're able to use scikit-learn in the next session. For people who are wondering, ooh, screen sharing is paused. I guess it's because I minimized the window. For people who are wondering how I define neural networks, for example, I'm actually, I wonder if I have an example here, but if not, I can share my parsec screen. Yep, I can share my parsec screen. This is not a great example, but essentially, oh, someone just asked if I can share the scikit-learn URL. It is this. Let me do that to everyone. So it's scikit-learn.org/stable, though if you want to install it through your terminal. Go share parsec. It's not a great example, mainly because I didn't define the architecture myself, but this does show a lot of things that you can do with something like Keras and TensorFlow, which you may have heard before. So currently I'm creating baselines for my thesis. So these are models that are control testing for me. So what I'd like to test my defined model to these comparisons, which represent the state of the art right now. So I have DenseNet 201, and I'm just using a model that was defined in Keras applications. And so I didn't actually define this model myself, because like I said, I'm going to be comparing it, or I'm comparing my model to DenseNet and to EfficientNet v3. But you can see that a lot of things you can actually define yourself, which are actually pretty important with machine learning, especially with the limitations of like graphics cards and all this sort of stuff. So for example, I not only have a generator for my training data set so that I don't need to load the entire training data set to RAM. I just generate subset of my data set. So you can do that through a generator function by essentially inheriting sequence from Keras-util. But not only that, but you can also define things such as custom optimizers. For example, this optimizer is actually for gradient accumulation because I needed larger batch sizes for my neural network. And so now there's a ton of optimizer-based or optimizer-related variables that I can set together. And then down here, I can go ahead and actually just sum all of my gradients together to do gradient accumulation in the first place. So that's pretty cool. There's Keras and TensorFlow if you want to do a lot more low-level stuff. We're not going to be doing that. but I'm essentially just showing what potentials that you may have when using other libraries to do more complicated things. Okay, no problem. And then for the last thing I'd like to show before we end over here is I'm going to go ahead and show this, which is, so this is Python being used as a replacement for, or as a website or server-side scripting language. So as you can see here, I have a ton of like strings, and then I'm using like, F strings to put variables within my strings, and then I'm doing things such as, conditionals within the strings itself. So I'm actually putting like if statements inside my strings, and this will resolve into an actual string that was resolved into not applicable or another string, which is the minimum C to the maximum C. So there's a lot of like complicated things you can do. And essentially what this is like a replacement for server-side JavaScript or PHP, which is most commonly used for server-side scripting or programming. And as you can see, this is an index to HTML. And if we go ahead and go to the website itself, so let me go ahead and do that. This is a website hosted on Google Cloud Platform for free, thanks to the Google Cloud Platform free tier. We can see that, you can use Python for way more than just, kind of like arbitrary, whatever, like data science type stuff. You can even use it for things like, front end or at least back end for server type computations, etc. So this is a project under another professor of mine where we allow multiple users to submit C values for particular plant species because we're trying to create coefficients of conservatism values. And, you can do all of your logic for all of these sort of stuff using Python. So it's much more general purpose than what I'm making it seem to be. And there are games that are written in Python. I believe EVE Online's like backend is Python. And there are programs, front-end programs that are created in Python. For example, the actual last thing that I will show everyone is for Base App, which is yet another project under the same professor. And I'm just gonna, I'm gonna wait for this to run really quickly. It may take a while just because it has to load TensorFlow libraries. But essentially, if I share this screen, this is an entire program that was created in Python and by Qt as well. So if we go ahead and I can go and select an image, this is currently under development, so hopefully it does not fail. Cool. So it says the image is blurred, which is fine because I did select the particular image was high blur. So this was a test image. But as you can see, this is a program that essentially does post-processing for you automatically and reads barcodes and all this sort of stuff. This is a project between me and a collaborator of mine, Caleb, who recently just graduated. And this incorporates a lot of things such as front end, a lot of libraries such as barcodes, as well as the neural network that I created in the paper that I showed you in the earlier session, where this neural network now exists within this program, and I can use Keras and TensorFlow to actually do all of my object detection type stuff within this image. So really, Python could be used for so many different things, not just like kind of like scripting, print out statement type stuff, but even things such as this. And then the last thing, not the last thing I'll show, but the last thing I'll say is that yes, Python is slow. But what's nice is that most libraries, such as the libraries we use here, are written in C and then have interfaces to connect or to talk to Python. So essentially, all of the functionality that you find here in this program is actually implemented through OpenCV, which is written in C or C++, I believe. And then TensorFlow is using CUDA code, so C-like code to run on the GPU. And then NumPy, which also uses C. And then we have some Python stuff in here. So essentially, Python is slow, but there are so many libraries that you can use that are written in much faster programming languages, such as C, and then can be interfaced or glued together using Python, making a lot of the coding much simpler because then you don't have to worry about other things such as garbage collection or whatever case may be. So yeah, that's everything that I'd like to talk about. This was way, way longer than I was expecting it to be, so I'm sorry. Everybody, I thought this was only going to be an hour, but it ended up being 2. Is there any other questions in terms of that? I do remember messing up like once or twice, so if there's any questions in regards to that, please feel free to let me know. No problem.
Thank you. That was good.
Thank you. That's nice.
Thank you, guys. I'm glad that everyone doesn't have any questions. And hopefully by next week, we can do a fun little project of like, language detection. So what we're doing next week is we're classifying words, whether they're English or German, using predefined models. And then we can go ahead and graph the accuracies of these different models in terms of how well they can, detect whether this word is from this language or another language. So I think the project next week will be pretty cool. Shouldn't take too long, but I will say it will probably take 2 hours, so just that. And we'll be going through the very start of like loading the data, acquiring the data, pre-processing the data for machine learning, and then sifting it through a neural network model. So I feel like everyone should look forward to that. Are there any other things?
It's August 13, 1 to 3 p.m., right?
Yes, I believe so. Yes, it is. August 13th from 1 to 3.
Yes, everyone, thank you. That's good job. Yeah, very great, brilliant. Yeah. One more things, like I'm going to post a survey, okay, on this. Please spend some time, filling out the survey, so that the NSF people, they will know that, okay.
Okay, I just double checked it really quickly, and it is 1 to 3. So 1 to 3 Thursday next week.
Yeah.
Cool. Dr. Liang, would you like to conclude this session?
Yes. Yeah. See you guys next Thursday, right?
Mm-hmm.
Yeah, 1 p.m. Hopefully everybody have got the link. Yeah. If you did not get it, please let us know. Let me know. Okay.
So Dr. Liang, next Thursday morning we also have another.
Yes, that one will be a seminar. Yes, next week you guys will be very busy. Next the Tuesday, and Dr. Shalom is going to talk about the application of the high performance computing in the data science. So he tried to just marry these two fields, HPC and data science. And the next Thursday morning, Dr. Jen, he's a professor in business. He's going to talk about the application of data science in the business. and also how to analyze the social network. Yeah, that's the whole story. And then next week, after next week, I think we will stop this year's program. So yeah, thank you everybody for your patience. Yeah.
Cool. Thanks everyone.
Okay.
See you guys next week.
See you.